ahead.
Well, I hope you enjoyed the break, got some more coffee so you can push through today. I think it's going to be a good, meaty, long day. So I'm pleased to be able to moderate this panel on Moon to Mars strategy and the future of space exploration. What we're going to do is I'll introduce each of the panelists one by one. They'll talk about their role and a little bit about their backgrounds, and then we have a series of questions we'll be going through to better talk about where we're at, where we're going, some of the key issues that we're looking at, facing, et cetera. And then we'll, you can vote on the, use the QR code if you have questions. And toward the end, we'll save a little bit of time so we can address some of those questions. So to start, just a quick overview of what this is. As a spacefaring people, we have pursued scientific and technological advancements to the great benefit of our nation. NASA, along with our space industry, has proven its ability to do things that are extending our space economy from low Earth orbit to cislunar space. And I think you're hearing a lot about that, during this conference. Our global partners have the moon in their sights, and together we will return to the moon and then on to Mars. Science has shown us craters and permanent shadow that might have water. Hydrogen and oxygen can propel us to even further destinations, creating opportunities for research and innovation that are full of possibility. The moon is our home base, a stepping stone to extend human presence and exploration throughout the solar system and beyond. And I think you heard a lot this morning from Deputy Administrator Melroy, on this and some of the, the plans, some of the accomplishments and so on. And so now we're going to dive a little bit deeper into the specific strategy. And we've got a great diverse panel here that each play a different role in that. So we're going to, hear their insights through a series of questions. So the first person I'd like to introduce is Amit. And Amit, if I can get your official title here. And oh, it's right. Okay, sorry about that. Amit Kshatriya, I knew I'd do this wrong. Kshatriya, Deputy Associate Administrator, Moon to Mars Program. And why don't you tell us a little bit about your role here?
Sure. Thanks for putting this together, and appreciate it. Well, that's pretty loud, so I don't know if everyone is this loud, but okay.
I think you're good.
I appreciate the opportunity to be here. It's a wonderful event, and it's great to see a lot of folks that I tend to normally see when we're out at these conferences, but it's really just a different kind of framework, and I really enjoy being here. The Moon to Mars Program Office was, which is what I'm managing today for Jim Free, who's the head of exploration at NASA, is essentially the implementation arm of the objectives process of the overall strategy. The way it's working inside the mission directorate and inside the agency is the strategy development, the objectives development process, which Pam, I can't talk about it more eloquently than Pam does in terms of why we set the systems engineering approach up the way we did, because we needed to have the elegance of it is that it's invariant under external pressures and budgets and other stimulus that's going to happen. We needed to have kind of an enduring approach, a resilient approach, and she speaks very profoundly on that subject. But when it comes to us, the architecture process as it's executed inside the mission directorate ultimately will devolve into, hey, these are elements that need to be fielded and tested. And right now that's what the Moon to Mars program is doing, and primarily concerned with the next 4 flights of the Artemis flight test program, which, as you guys are well aware, is pretty ambitious in terms of the objectives we're trying to achieve in terms of capability, establishing a return to landing capability, and in this case, just similar landing capability, as well as the ability to aggregate in cislunar space primarily are our driving objectives in the test program. But as new capabilities get injected into the architecture and get close to the point where the formulation activities become more kind of real, is when we would take them over inside the program office and go field the project or development activity.
Great. Thank you, Amit. Okay, the next I'd like to introduce Joel Kearns, Deputy Associate Administrator of Exploration, Science Mission Directorate. And so, talking from a science perspective, Joel, why don't you talk about the Moon to Mars objectives?
Hey, thanks, Julie. It's a real pleasure to be here today. So I work for Nikki Fox, the head of science at NASA, and I've got the pleasure of running a group within Science Mission Directorate called the Exploration Science Strategy and Integration Office, which looks at planning for science related to humans at the moon and eventually at Mars and eventually other destinations. But I also have the pleasure of being the program director for Lunar Discovery and Exploration, which is NASA's moon science program. And that includes how we're implementing science on the moon, both with robots and with people. And with robots, we're using commercial lunar payload services, where we're actually buying the service of getting our equipment to the moon and our data back using approaches developed by companies in the US instead of doing our own lander or buying our own rocket or things like that. So up on what I wanted to show here is that this is our little spiral chart that talks about all the missions coming up to the moon where there's a major US contribution or presence or leadership. These missions are either in orbit or in cislunar space, or they're going all the way down to the surface. And there's a lot of missions, everything from the robotic missions to the first landing on Artemis 3. And if you were to look at a chart like this, say in 2016, you'd probably have 2 missions on it. You'd have Lunar Reconnaissance Orbiter, which has been doing maps of the moon since like 2009, and then you'd have future missions someday. But of course, it looks really different today.
Yeah,
there's a lot
it
going
does.
on. If you go to the next chart, if you're going to show the charts. And in implementing these landings commercially, we have 4 companies doing a variety of services for us to bring things to the moon. Dan Hendrickson is going to talk about one of those. These are some photos of what we think are going to be the first 2 relatively soon that are going to land on the moon. And if you go to the next chart, you can see we have queued up a large number of industry-enabled lunar landings for science that'll go on through 2027. If you see little icons of ships, that means the companies have been picked. If you just see a blue box, it means we know the science that we're going to do, but we don't have the companies yet. So in addition to that, one of the fun things I got to do at the end of 2021 was lead the science part of the team that helped develop the Moon to Mars objectives. So when you look at the Moon to Mars strategy and architecture, you see those 26 science objectives. I had the pleasure of helping to bring those together with a big science team, getting them reviewed, getting input from the external community, and working with the other mission directorates like Amit's and Michelle's to make sure that we all had a consistent vision and we could explain it to people.
Great. Wow, I really like that chart you had with all the different lunar missions. That is totally awesome.
Yeah.
Hope you guys are going to do a really good job of publicizing that and getting the public involved with that. That's going to be really cool. Okay, I'd next like to introduce Michelle Munk, Chief Architect, STMD. So Michelle, tell us a little bit about yourself.
Yeah, thank you, Julie. Thank you for having me with this esteemed panel this morning. Yes, I'm serving as the Chief Architect for the Space Technology Mission Directorate, and we are the technology development organization specifically within NASA. Been in that role for almost 2 years now, and my role is really to work with Exploration Systems Development Mission Directorate, Science Mission Directorate, Space Operations Mission Directorate, and Aeronautics to make sure we're investing in the correct technologies and helping to build those relationships to get those technologies infused. So within Space Tech, we have a strategic framework of technologies in the areas of go, land, live, and explore, really the 4 functions that we think of doing as we're doing space exploration. And we have about 18 capability areas that we're trying to mature to achieve certain outcomes. So I think those outcomes are very well aligned with the Artemis program, as well as all the other science missions that we do across the solar system. So I've been working with science for a long time, as well as exploration. Personally, I've been at NASA for about 35 years, and I was just coming across some documents from the early 1990s. I've been working on human lunar and human Mars architectures for that long. So, the Artemis architecture is really exciting to me personally, and I'm really enjoying the role of Chief Architect to try to integrate and enable those missions with technology developments. And so we'll talk more about that as we go through the panel. I was also fortunate to be on the team, as Joel said, to help with those infrastructure objectives that space technology is stewarding for the agency. So we have 9 lunar infrastructure objectives and 4 Mars infrastructure objectives, which are really going to help us build that sustainable presence on the lunar surface and enable a transition to a commercial lunar economy so that we can use our resources to go further into the solar system onto Mars. Thanks.
Great, thank you, Michelle. Okay, next, Dan Hendrickson, Vice President, Business Development, Astrobotic Technology. Tell us a little bit about your perspective here, Dan, since you're the first non-NASA person to hear from today. Of course, I'm non-NASA too, but you know, I'm the moderator.
Well, good morning and thank you. My name is Dan Hendrickson. I work at Astrobotic. We're a lunar logistics company based in Pittsburgh, Pennsylvania. And we've been in business since 2007. So about 16 years we've been focused most immediately on lunar logistics and making the moon accessible to the world. And to that end, we are now approaching our first mission, as Joel had on his slide. We're preparing for our first launch of the Peregrine lander, which is carrying 16 customers from around the world, representing 7 nations in some form, whether company, government, university, or nonprofit. That's the completed vehicle, fully tested, gone through the full battery of environmental test campaign that you'd expect for a typical spacecraft. That's inside of our clean room in Pittsburgh, waiting for the green light to ship from ULA. We'll be flying on the Vulcan Centaur vehicle in December. So that will kick things off. And then we're also in parallel developing the Griffin lander, which is going to carry the NASA Viper rover in November of 2024. So a couple of lander missions coming up, and then you'll see on the screen as well, we consider ourselves a true end-to-end delivery service, and so we're developing rovers as well. So we're providing capabilities for payload customers around the world to be able to take advantage of low-cost lunar delivery and to be able to make meaningful use of the science, exploration, and commercial opportunities that we believe exist. And in the context of the Moon to Mars strategy, we're really excited to offer and provide platforms like you're seeing on the screen to help enable the nation and the world really to achieve those objectives. And so we're one player among many in industry, obviously, to help make these objectives a reality. And I think that's what makes this push to the moon and onto Mars different than ones that we've had in the past and in prior decades. These platforms, these companies are ready to serve and to help to buy down risk and to achieve these objectives.
Great, thank you, Dan. Okay, Daniel, I know the audience probably knows you already because you were on the earlier panel, but why don't you tell us a little bit, why don't you remind us a little more about yourself and then how you fit into the Moon to Mars strategy.
Yes, thank you. So first of all, good morning again. I feel very honored to be on this panel because I think it's a great panel. It shows, first of all, that the commercial sector is represented and, of course, the institutional with NASA. And I just realized that I'm the only non-American in this panel, which is also an opportunity and showing a bit what it is about, the exploration. I think I would like to start by thanking NASA for having put forward the Moon to Mars strategy, because it is really an opportunity for all international partners to reflect about their own positioning, and this is exactly what we are doing on the European side. We are right now at the European Space Agency refining our exploration strategy. We will have one single strategy for one continent, but clearly with 3 key destinations: low Earth orbit, Moon, Mars, and I should say even beyond, because at the end, ultimately, it will be beyond Mars. But what matters is that now that we break down this overall concept of Moon to Mars strategy and our European strategy down into concrete priorities and elements. So you have on this chart just a few elements of highlighted in blue. What is the European contribution right now? That's a snapshot. So in low Earth orbit, we have, of course, our contribution with Columbus and in the past the ATV modules to the International Space Station, and we have additional infrastructure elements like Node 2 and 3 and conducting, very important, also an important scientific program right now on board of the station. We have here as well as a symbol, the Ariane 64. Let me recall that before I've taken up my new job on the 1st of July, so it's quite recent. And before I was director of space transportation, and I underline this here because it's so important to fully embrace the access to, transport in, and return to Earth in an end-to-end approach when we speak about exploration. So for me, before going more into detail, it's really two topics. The transportation dimension is fundamental, and the farther we go, we know the relative cost will be higher, so we have to take this fully into account. And second, and this is important in Europe, the scientific dimension of what we do has a high value. So we have also a way we justify, in particular, what is on the right end of this slide on Mars, also with what we do in terms of scientific activities. Ultimately, we want to have a human on the surface of Mars, but we really need to learn a lot still in order to understand what is necessary in terms of what it implies on the human body. And this is where I think the link with the moon is so important. Gateway here is on the picture. We are right now conducting or are preparing instruments to see what is the impact on the human body in terms of radiation. How do we react within IHAP or within the gateway, outside of the gateway? We have so much to do. We need to do science also, take into account when it comes to Mars again, to drive mission selection. The way we select missions will have to take into account some scientific aspects. And ultimately, there is a value at the end when we are conducting missions to have also the scientific data as such, which will really be crucial for future generation of scientists. So transportation and science, two important pillars into that. 3 destinations, low Earth orbit, Moon, Mars. Now just a word on Moon and Mars. You see here different elements. Gateway I spoke about, IHAP. There is also ESPRI, another important element. So you see that if you combine it with the European service modules, that we have quite a substantial participation in the gateway from the European side. We will have a lander, Argonaut. We have with Dan here also a representative from the commercial sector who also works in this field. But I see this as an opportunity. I think it's an opportunity because we will have so much cargo to be delivered on the lunar surface that we will need a lot of different efforts. What is missing right now is the overall coherent approach, the architecture, energy, communication, mobility, operations. How are we going to conduct that? And I think this is the big challenge that we have now as a next step on Moon, later on Mars, and we are here on the European side to have a end-to-end exploration program. If I take the Argonaut as an example, it's clear that it is first a contribution to the Artemis program, but it's also an opportunity to have other type of cooperations, and this is how I see it. So there is kind of self-determination in all the master plan you see here from the European side, but at the end, all this will only be realized if we have a common shared end-to-end approach. And once again, I conclude where I started. I think that the Moon to Mars strategy from NASA is allowing us really to go the next step.
Great. Thank you, Daniel. I really like your comments talking about how it's going to take, how we have to bring all of this together, because the collaboration here is totally in line with the theme we have in the conference too. Yeah. So, and this is like the ultimate collaboration. So, okay, let's start with a few questions. Okay, first one. Moon to Mars objectives are expanding into architectural elements. This process incorporates analysis across all of NASA and important contributions from U.S. industry and international space agencies and partners. How did this come about? How do you see it evolving? And I imagine each of you have touched this in different ways and seen it evolve, so I'd like to hear some perspectives on that. So why don't we start with Amit?
Yeah, I talked a little bit about it at the beginning, the rationale for the systems engineering approach that we're using with the objective strategy, I think, again, was driven by that need for that constancy of purpose, to have a plan that we're going to stick to, that's invariant under a lot of the externalities that we're going to endure as an industry. I think, and making it objectives based gives us that kind of top level resiliency. In terms of where we're headed, I think, the last year, and I think it was probably right after this conference this past year, where we had our first architecture concept review, where we laid out kind of the strategy in terms of how we're discretizing the big exploration segments. The first one that we baselined last year was the human lunar return segment, which is essentially, the test flights of Artemis, right? In terms of enabling the capability I talked about before. But as that baseline being established, we've engaged as much as we can with industry, with the partnerships, and it's really a pleasure for me to have Daniel, on the stage, just because of we went to the moon together in November with ESM and with Orion, and that's the kind of collaboration and partnership that we're going to continue to encourage as we go through this process. But the industry and international workshops that we've engaged in since that concept review have been very, very well supported by everyone, all of our stakeholders. And here in 2 or 3 weeks, we're going to get together again at KSC and go through our next iteration of that review. And our objective is to set up that yearly cadence of feedback and incorporation into the strategy. And so that's where we're headed. And I think, as we sit here, when we sit here next year, we'll be able to talk about some of the questions we asked at ACR 23 in terms of Mars and those segments, and how we're starting to look at new elements coming into the plan.
Great. Yeah, looking forward to next year already. What do you think, Joel? What's your perspective?
We were really fortunate in space science in the United States in that we have a really strong American scientific community, and we get really good and focused advice, recommendations on what scientific questions to address and what even space missions to do through what are called decadal surveys, which the U.S. government commissions through the National Academy of Science, Engineering, and Medicine. And in the 5 traditional scientific fields in space and earth science, we have earth science, heliophysics, which is the study of the sun, and space weather. And we have astronomy, we have biological and physical sciences, which are the laboratory sciences, life sciences, as well as physical experiments in space, and then we have planetary science. And we've been really, as I said, fortunate in that we get very specific advice. So it was actually pretty straightforward to us, being guided by that advice in how to construct the science parts of the Moon to Mars objectives. Now, because these look out about 10 years, we had relatively specific advice for the Moon, and it wasn't quite as specific for Mars. But we also have really strong advisory groups in the United States. We have what are called the Lunar Exploration Analysis Group and the Mars Exploration Program Analysis Group, which also participated providing advice to NASA when these objectives were being drafted, attending the U.S. workshops. Mm-hmm. And of course, science has very strong international collaborations that I'm sure you're all familiar with. So then as we progress, so it was pretty natural from our point of view to get objectives established for the first 2 planets that humans will visit coming up. And then, as Amit said, talk about how you develop an architecture, what systems or elements you end up with, and eventually what missions or campaigns you end up laying out to realize those objectives. And for our community, we had those objectives at a relatively high scientific level of description to make them commensurate with the other objectives. But you could see how those end up flowing into particular campaigns and the futures and missions and what type of hardware and software you would need to do it.
Great. Thank you, Joel. Okay, Dan, as the commercial guy here, how do you view this? You've been a part of this for quite a while, and I've seen this evolve, so why don't you give us a few words on your perspective?
Yeah, I think we have to acknowledge that developing these kinds of objectives is a hard process. And I think, I really commend NASA because I feel like when I read the objectives, I feel like we're heard in industry. I can trace some of the investments that we're making as a company, as well as some of our competitors as well, and I can see the influence and the dialogue in the actual document. And so I think it's a great foundation for all of us to be working from, and I'm really excited. You use the word evolution or evolving in the question, and I think what's going to be so exciting is when you see the map that Joel just showed of all the missions on the moon. That's just such a huge opportunity to advance on all those different objectives, and we have the tools, we have the commercial partners, we have the landers, we have the missions coming up, and I think it's going to be exciting to strike things off the list and to evolve it over time, to change and to adjust, because certainly I think once you see these missions fly, we're going to learn things about the moon and operating and forward feeding to Mars, such that some of the objectives might need to adjust over time. And I think to Amit's point about this being a process that occurs over time, we can provide that feedback not just from industry, but from actual missions with real data going through the experience. And I think that's a lot to be commended.
Great. Michelle, I think you might have a few comments about technology here and how that fits in.
Yes, thank you. So I think, Amit said it really well about the overarching strategy and the need for that resiliency and constancy of purpose. So, as a mission directorate, we were really happy to see that. We're fully behind it. I mentioned those architecture studies that have been going on for over 30 years at NASA. The critical technologies that we need really haven't changed, right? We still need to establish, precise landings. We need to, have good space transportation. We need, exploration tools. But I think the objectives really created that bridge and that pull between the technologies that we've all been thinking about and working on for many, many years, and really solidified the fact that we're going back to the moon in a sustainable way to stay this time. And that's really the characterizing feature that makes a lot of the technology so important and the infrastructure so important to support that sustainable presence. So, when Pam told us at the very beginning of this process, I want 24/7, 365 presence on the moon. Wow, that changes things quite a bit from what we did in Apollo. So, creating that structure for the need for the infrastructure, and then allowing the space economy to fill that role is really central to space technology and the investments that we make. So the objectives have created that pull. We are getting more integrated. I'd say, as Amit explained, the architecture concept review process, the human lunar return segment, those technologies, were invested in 5 to 10 years ago and are now in execution. But we're looking out always as technologists into the next 5, 10, 15 years. And those are those segments like foundational exploration and sustained lunar evolution, where the infrastructure and the robust lunar economy and some of those technologies for living off the land, like in situ resource utilization and autonomy and mobility, really come into play and are critical. So we're happy to be part of the architecture concept process, and creating that pull and seeing where our technologies can make really big differences in making a resilient, sustainable architecture.
Great, great. And I think it's really cool about how NASA has linked everything. They go science, technology into the architecture, and how everything is being linked together. So, I'd worked with NASA for multiple decades, and this is probably the most integrated I've seen it, and it's great. It makes use of everybody's skills, and it also recognizes all the different things we need to actually make this a success. Okay, let's switch gears a little bit, talk about Artemis Accords. Okay, we continue to add more signatories. I guess the question, what roles do we see partner nations, and as we bring more and more smaller space programs or space agencies into the Accords, how do you integrate them into this process? And at first, I'll start with Amit, maybe to just discuss a little bit about the process and how you're involved with that.
From the beginning, as I mentioned earlier, certainly Artemis, as it was formulated even before the objective process, was an international program, and we learned more than I worked space station before I had the privilege of coming to exploration, and the international collaboration, the dissimilar capability that our partners bring, the advocacy across the world was absolutely essential to the success of that program. So we played that forward directly into Gateway, into the way we constructed Orion. So the international collaboration is in the DNA of the program. It's baked in. In terms of how we're encouraging new collaboration, I think, of course we have the international workshops we're doing on the architectures and how that flows in. That's really how we'll integrate new partners, depending on their level of maturity, into the overall plan. We're not integrating them onesie twosie. Hey, they have a thing they want to go do. We're trying to continue to evolve the overall structure of the architecture and allow them to contribute to that. We're in places where they align with their own unique objectives. But we have that plan. That plan is what will integrate the efforts together. So that's, and that international engagement is part of the architecture process. I think make sure that's grounded in their continuously evolving, needs for their own purposes. But also I think what's super important with the Accords, what it's doing. I was in Baku just a few weeks ago at the IAC, and you can see it's a very interesting time right now in the world. And lines are being drawn, and I think what the Accords are doing at least for us, and I think for our partnership and for everyone, that's I think sees the world and sees exploration the way we do. It's making that commitment to each other that's how we're going to explore together. It's very, very important, and I think that Pam talks about where we're leading internationally. It's not just about competitiveness. It's not just about the geopolitics of it. It's about our values. And to me, that's more about what the Accords are about in terms of how we're bringing in our partners. Yeah.
I'm sure Daniel, you probably have a perspective on this that you can share, maybe.
Yeah, thank you. I think it's really a great question. Let me just start by a small disclaimer. ESA is not a signatory of the Artemis Accords. Of course, our member states who sign them. But let me bring to the table a general view on it. And I think besides the geopolitical dimension, which is certainly a strong argument in itself, for the exploration program, I see three key topics. Because at the end, what we want is a robust and resilient approach. And if we really want to go down the robust and resilient approach, I think there is a notion of interoperability to be secured first, meaning if we have to have an integrated technology roadmap for sure, but we also have to define the standards on the interfaces right now. I think this is a key enabler in order to really go to an end-to-end architecture. The second element is to be complementary on critical infrastructure in the sense that we may have on some critical aspects certain redundancies. But if one fails, it must be done in a way that the other can take over and vice versa, meaning in the way that when it comes to communication, I can perfectly imagine that there will be some contributions by some participants to the Artemis Accords on some elements. Some may be commercial, but at the end, it must make sense overall. And the one has the capability to take over the other one on the critical aspects. And the third element, I think it's a great opportunity to also bring on board new actors, smaller countries, which may have, let me call it, mission of opportunities. Mm-hmm. And this shall fit an overall single architecture. I mean, it is not just going there to be there. It's going there to do something more together with the others. That the sum of 1 + 1 becomes 3. And I think this is essential. And for that, it requires leadership. It requires a clear overall architecture. And it's all about that in the upcoming months.
Great. Thank you, Daniel. Joel, how does science play into Artemis Accords? What's your perspective?
Well, I think, the Artemis Accords kind of lay out a framework of cultural norms of how we all want to treat each other. And as part of that, we do want to encourage our Artemis Accords partners to really take part, in the adventure that is Moon to Mars, and starting with Artemis at the Moon. As I said, we have a long history in NASA science of working with partners that have a similar interest in pursuing space science questions, some of which Daniel talked about in the chart that he showed. I didn't show it in specifically any of the charts I showed, but there's actually a pretty substantial international component to several of the commercial lunar payload services industrial missions. Remember, those missions are not NASA missions. NASA is contracting with these companies to deliver our scientific equipment or our technology experiments to the moon and get our data
For
back.
one handheld?
In some cases, we're doing that in partnership with international agencies or companies through those agencies developing part of the equipment. In some cases, we are, within our NASA group of experiments we're bringing international experiments with us. And in some cases, because we have encouraged international organizations as well as US organizations to go directly to those commercial lunar payload services companies, because they're the ones running those missions. Some companies like DANS and Astrobotic, they have had international organizations pay them to go be part of their Peregrine Mission 1, as many of the other CLPS providers have offered. And so we routinely get requests to develop or be briefed on certain ideas, particularly from emerging space nations, and we're always open to that. For example, we've established even more formal opportunities. For example, on the Artemis 3 first human landing mission to the South Pole, we ran a competition to determine what experiments, physical hardware we would bring to the surface and the astronauts would deploy on that mission. And although we want to choose US experimenters from that, we also made it open to experimenters from the international community. Not that we would fund their experiments, because we don't do that, but it would offer them the opportunity to compete to be taken to the moon on Artemis 3. And we're in the middle right now of doing the reviews and the evaluations of all those proposals for Artemis 3.
Oh, that's going to be interesting, because now, especially if you bring in newer nations to space, you're going to be helping them learn that whole process of how you would do these experiments and so on. So hats off to you guys. That's great. Okay, let's talk about partnerships with industry, and I'll probably ask Michelle and Dan to talk about this. The partnerships, NASA's done a lot of work in changing how they work with industry to try to get us all ready for trying to take advantage of what industry can offer, make things commercial when it's the appropriate time. And certainly you guys have led the way with many of your types of technology offerings and programs and so on. Why don't you talk a little bit about tipping point and other types of ways of doing technology, and then we'll have Dan talk as a recipient, maybe talk about this topic and how it fits into the overall Moon to Mars.
Okay, sure. We, in the Space Technology Mission Directorate, we have 10 different programs that we use as mechanisms for maturing technologies, all the way from low technology readiness level and academic grants, all the way up through technology demonstration missions and really everything in between. We have a robust flight opportunities program, which is a cadre of vendor providers who can provide suborbital flight tests or zero gravity parabolic flights, lunar gravity flights, as well as we're getting into orbital space now too. So, many different mechanisms and opportunities for partnerships. So we run the Small Business and Innovation Research Program for the agency, where of course we are trying to spark small businesses and really help them accelerate their developments. But as Julie mentioned, some of the most impactful, I think, mechanisms that we have invented over the past 5 years or so are called tipping points and announcement of collaboration opportunities. Tipping points in particular are really, cutting edge mechanism for us, as well as really meant to accelerate the infusion and commercialization of our technologies so that industry can really take off with them. And so tipping point opportunity is where a company puts in some resources of their own, usually partnering with NASA centers, but not necessarily, for expertise or testing capabilities, and really identifying a technology that is at the tipping point, ready for commercialization, but it just needs that last little push. And so in our latest round that we announced a few months ago, those resulted in funded Space Act agreements. So we're trying to move these awards along more expeditiously to give more flexibility in the commercial providers' desires and requirements with less government oversight, less, formality from a formal government contract. And so, we're seeing a lot of acceleration in the community with technology development with that type of partnership. And we hope to get the results of those. We've had some awesome results so far, but these new ones are really going to, I think, spur more commercialization opportunities.
Great. Dan?
Yeah, we're really excited to be a part of the Tipping Point program. It's really been a success story, I think, across industry. In our case, we've been able to advance several technologies like our cube rover that you saw footage of. Wireless chargers is another example that we want to utilize for the lunar surface. So those are more terrestrially based, but the most recent Tipping Point award that we were a recipient of is for a program that we call Lunar Grid Light. And we have ambitions to deploy at the South Pole a microgrid for power generation and distribution, which that's a large effort. That's a very hard thing to do. But Tipping Point has allowed us to sort of take a bite of the elephant one at a time. And so technologies we've been able to develop terrestrially, but then with Lunar Grid Light, we can actually go all the way to the surface as a payload on board one of our own lander missions and really raise that TRL and prove, in the case of Lunar Grid Light, that it's possible to transmit across kilometers of power transmission across the surface using cabling. So that's a really, I think, a unique program where we can align it with our industry roadmap and like I said, sort of incrementally buy down risk. And what's nice, I think, when you zoom out is that it actually connects then back to the objectives. So if you look at the lunar infrastructure objectives, that first one about power, that's what Lunar Grid Light is attempting to address with its next piece and really trying to put the keystone in for a broader microgrid development. And it helps us to do that. It helps us not to be too ambitious all at once, but we can buy down the risk and develop one at a time.
Great, great. Okay, as we start, I've heard a lot about, what we're all working on today, each of your different perspectives. Now, as you're looking forward, and I've heard a little bit of this from you already, but I'd like to ask you specifically, what do you see as the next step in the Moon to Mars objectives? What's right in front of you? What are you going to be doing over the next few years? I'll start with Amit.
Well, the process itself, I think I'll let the rest of the panel talk about, because it really is, driven by their needs. We go where Joel tells us to go. They threw down and they opened up the last samples from Apollo 17, and they said, okay, so what we have to do as a program, with the 6 programs in the field that are operating, trying to get the missions together, we have to perform. We have to fly. And none of this matters if we don't keep moving. We have to make smoke and fire. We have to keep going. So we're going to do it the right way. We're going to get the right, kind of flight test objectives done in the right order. And we're thinking through that really hard to make sure we're doing things in the right sequence. But at the end of the day, our mandate is to give us enough, momentum to keep moving. And so much of that is driven by our performance as a team. If we don't get these missions off, then not just the interest of the community, but all the brilliant minds in the room that are thinking about the next steps and enduring presence, et cetera. If we don't do our jobs and get us back there, then we're going to be doing them all a disservice.
Yeah, we all have to perform.
Yep.
Michelle, what do you think as you see next steps here?
Next steps, get that infrastructure in place on the lunar surface to support all the elements and allow the exploration and the science. Obviously, our first orders of business are power, comm, and position, navigation, and timing, enabling mobility and autonomy to really use the cruise time most efficiently when we get them there. And just really make sure we're focusing on the right technologies and allowing our industry partners to help us really enable the architecture. I think, we want to be there to have the technology ready when Amit runs into a tough problem, right? I don't want technology to be the limiting factor. So we need to stay ahead, and we need to have some successes and make sure that we can help build this resilient architecture.
Joel, what do you have a lot of things in front of you. So if you had to say, here's my next steps, what comes to mind first? You know, what are your priorities there?
Well, you know, in the near term, we're very focused on putting all the science management and science activities in place for those near-term Artemis missions that Amit talked about, the flight test missions, which are in human lunar return campaign segment. So for last year, we picked the individuals who'd be the project mission scientists for Artemis 3 and Artemis 4. We picked an internal, NASA internal science team, which you can think of as being a science mission team for Artemis 3 and Artemis 4 and beyond. And as I mentioned, the scientific instrument competition going on now, but we just finished a competition to pick what's called the geology team, which are the group of US scientists who will guide the flight operations and the flight crew members, and actually what specimens they will pick on Artemis 3 at the South Pole for the first South Pole landing to answer some of those major science questions. So that's all in the short term, but looking more at the farther term in the years coming up, it's time to, and Amit mentioned this earlier, but it's time to look at the next level of detail for the later campaign segments, humans to Mars, which we're addressing right now internally at NASA, and then foundational exploration and sustained lunar exploration, because there's a number of scientific questions in the Moon to Mars objectives that can really only be answered in those campaign phases. So we have to look at when you break down the top level science objectives to the next level objectives, how do you decompose them down to get them into specific campaigns, into specific missions? And for certain missions that the scientific community has very clearly recommended us to accomplish, like a mission called Endurance A, which is to bring back specimens from the South Pole Aiken Basin on the far side of the Moon, bring them to the South Pole, a relatively large number of really well-characterized specimens, so we can answer long-standing scientific questions about the age of that impact. Were there cataclysmic impacts going on around the time life was first appearing on Earth? How are we actually going to do that? How are we going to implement it? What scientists are going to be involved? What type of elements does science need to bring to the table? And how are they going to interact with the spaceflight elements that Amit and ESDMD are putting together? So there's some very short-term things, and there are some very urgent things to do for the long term, for the further campaign segments out there. I think that plan, we pretty well understand that plan, what we need to do.
Good. I think we've heard about what your, Dan, I don't think it's a surprise what your very short term is, because you got a mission coming up here. But you said priorities, that's got to be one. Are there others, or?
That's the priority, yeah. It's time to launch and land. We've been talking about this for 16 years as a company. It's the moment. It's time to do it, and it's time to deliver on Peregrine. It's time to deliver for Viper. That's our focus, and that is, I think, crucial for enabling all of these other objectives. Is we've got to start to open the Moon up, and it's going to be these missions that will open the era. So it's time to execute.
Great. You have anything to add?
Yeah, I just would like to add 2 points here, let's say a bit from the non-American perspective, but to underline it. Number one is certainly that, we all recognize that the Moon to Mars NASA architecture will be reflected in the ISEC Global Exploration Roadmap. And this means that we need for all the international partners that we ensure the coherence of the future technology maturation. I think that these assessments have to be done jointly for Moon and Mars in order to make sure that we have here really a coherence. And the second point, I miss no opportunity to bring it, it's about the interfaces, because if we want really to have among the signatories of the Artemis Accords, once again, but a really open architecture, we have to work about interfaces, and I think there is a value in also competitive solutions. But if we want really to keep up this possibility to run competitions by industrial actors, of course, we also have to make sure that we really, and maybe one day some competitions may go across the Atlantic, so we have really to make sure that we have this right set of the architecture at the beginning of the interfaces.
Great. Thank you, Daniel. Okay, we've got about 10 minutes left. I'm going to ask a few audience questions now. The one that got the most votes. how do you think humanity's expansion rate will change once we surpass initial barriers like the moon and Mars exploration? Well, those are huge barriers, or not barriers, big pieces we got to get past, but this is a little more forward-looking question. How do you think humanity's expansion rate will change? Anybody want to take that one?
Let the PhDs handle that one.
Pardon?
Let the PhDs handle that one.
I would say that I personally think I'm really bad about predicting the future, right? I always think that things are just going to be a linear extrapolation of where they are today. And if you go back and think about how different software and computing power is than say, a couple of decades ago, or what's going on in terms of launch vehicle cadence now, right, and delivery, it's really, in those areas, it's really different than what people would have extrapolated and expected. So, but I really think the way to answer that question, because I can't predict how that's going to work, but the real question is, do a large number of people really see value in going there? That's what's going to pull people. It's, yes, government policies and the international community can set targets, they can provide some incentives, they can make sure that there's a good regulatory system in place, but the real question is there something, what is a value there that drives people for themselves that they want to go? Yeah. And I don't think we know that yet. We have some ideas, right? In science, we're doing investments on the moon to look at what's called the volatile cycle. Things like water ice. Is water really present at the south pole of the moon in bulk form, right? Is it not hydrated minerals or hydroxyl groups? Because there's a general thinking that, so for one thing, from a scientific point of view, that's really important to understand, because that gives us an idea how water got to Earth, right? And why it's at the state it is today. For people that have more of an applications bent, there's a number of people that would really like to know if there's ice at the south pole of the moon, and if so, how much, where is it, what are the impurities in it? It's going to be things like that drive out to the moon and out to Mars and further out into the solar system. It's going to be what's the value that people think they can get from it.
That's interesting.
Maybe just to jump on what Joel said, we are here not in a foresight workshop, for sure not, and I have no crystal ball neither, for sure. But I mean, at the end, we are fundamentally explorers. We are. This is in the human nature to go further. So I think this is an element. But I'm totally with you, Joel. At the end, it is about the value. So the question is it a pull or a push approach? Is it a pull aspect? Because we also see that there are opportunities beyond scientific aspect. There is, of course, a question of resources, how we access these resources, whatever they be, by the way. But that's another dimension, or a push dimension, because let's face it, we have seen the dramatic evolution on our small blue planet this summer across the world. Yeah. I mean, there are some effects on climate, and if you project yourself, and if you have children, you must ask yourself, what will be the future of our spaceship Earth? I mean, if you really go for, at the end. And I think it will be a combination of pull and push for sure. I hope it will be more the inspirational aspect and pull. But okay, we have no crystal ball here, but I think it's our collective responsibility to enable that it can happen.
Great.
Yeah, Amit? It's interesting that the question was asked that way. I agree with Joel and Daniel in terms of the motivation. What I really would hope to see, though, is the exploration of the solar system kind of. It's all about perspective, right? I mean, we're in a position where if we can bring perspective of what it's like to, regardless of where it is, the moon, the Jupiter icy moons, if it's Mars, etc., all of these places are very, very difficult places to be, right? And I kind of hope that, and we still should go, we have to go because we need to explore it, and it'll enable incredible things, but I hope that a righteous outcome of this process, of the exploration process, also feeds back into the way that we're treating this miraculous planet, which is really just incredible. If you look at what we know about, the planets that we've witnessed in our near-term regions of space, it's incredible what this planet is. And so I really hope that at some point that it's not necessarily a question of just, can we expand and can we keep? Of course, I want that to happen, but I also want that perspective to feed into how we're managing this incredible place. And so I think that. Hopefully that's an outcome too.
Any other comments, or should I move on? Next one.
I don't think I could add anything. That was great.
Yeah.
I've got a comment, and I think that we don't quite know yet what it's going to be like when we have humans really actively interacting with robots. We're out in the far frontier.
Yeah.
The Apollo astronauts did a fantastic job of being field scientists for geology back in the 60s and 70s. Really changed our understanding of the Earth and Moon system. All the nations of the world that do space science and Earth science missions have gotten really, really good, very successful at doing robotic teleoperated missions, either on planetary bodies or in orbit, right, remote sensing. But if you think about the changes we've seen, again, in the decades in computing power, in software, now in VR and AI, I don't think we understand yet what that symbiosis or synergy is going to be between humans and robots further out into the solar system. What is that really going to look like? There's a lot of folks that have ideas, but we're at the very cusp of finding out.
Yeah, no, when I saw Afua's, when she ran that video, and you had some of the more futuristic things with some of the robots and that, I started thinking, oh my God, I've only been focused on us going and, rovers, but now we have these intelligent, potentially AI robots. What about us? And then it starts, really expanded my thinking on that yesterday. That was interesting. Okay, we only have time for one more. Let's see. Okay, this will be an interesting one. What is the dynamic you see between private companies and NASA for building commercial lunar bases? Anybody want to comment on that? Dan
Sorry,
might.
could you repeat the first part of the question?
Pardon?
Could you repeat the first part of the question?
Yeah, what is the dynamic you see between private companies and NASA at building commercial lunar bases? It's probably like who leads, who follows, who sponsors, how does all that work?
Yeah, I mean, I think it's a push and a pull for sure.
Yeah.
I think, for us, we're trying to push, for instance, the idea of LunaGrid and providing infrastructure. In that case, though, we want to have sort of certainty of knowing, are we building in the right place? Is this where the government customer is going to want to be? Is this where the commercial customers are going to want to be? So it's a dialogue, I think, and it is going to be a push and a pull. We're going to take demand signals from both sides, but I think we also have to be very realistic and recognize that the Artemis demand signal is going to be the strongest one to start. And we're certainly going to have to work very closely with our government counterparts on that and take that demand signal most seriously to start.
I think it should be, and I think it's an evolution of the approach that, I don't want to be too, kind of simplistic about it, but this is what we've been doing as governments for centuries in terms of how we're pushing the envelopes for exploration, right? There are certain boundaries where we socialize risk and we take it on behalf of, the exploring entity, and then we let the private sector kind of fill in after we've taken the risk out of the equation so that it can be, fertile for private development. Space station is a great example of that. For over 30 years, we built that infrastructure. We did it in partnership, and at this point now, because of what space station enabled in terms of the private launch industry, and in terms of now all the potential new destinations, the capability for all of the industry here that's kind of looking forward to what the moon's going to offer. It's the same process, I think. And so as we continue to go, we take the risk with us, we socialize the risk, we burn it down as much as we can, and then when we're done, we move on, right? So I hope that's a righteous outcome of this, certainly for lunar bases.
Great.
I think just to add on to that a little, that's exactly what I would say. In addition, it's a logical extension of the basic utilities that we're thinking about now, power and comm, and to build habitats on the surface or deploy habitats and set up, more broad infrastructure, places to live and work and do all the functions you need to do in your life and on your mission. So, I agree.
Well, we have 1 minute left. I'm trying to see if there's any simple ones here. Here's a simple one. When does ESA expect to publish its refined exploration strategy?
Thank you for the question. The objective is March 2024 at the occasion of the next ESA Council.
Great. That was a simple one, right? That was a discrete answer as opposed to a little more crystal ball and looking out. So let's see. Let's treat this one like a lightning one. And first thing that comes to mind, what has to happen? What's the big technological thing that has to happen to go from Moon to Mars? If you had to think, what's the big thing standing in my way? What comes to mind first?
Propulsion.
Propulsion?
I'll let you guys.
Highly reliable avionics.
Power.
Howard? Michelle? You're the technology.
Entry, descent, and landing.
Yeah.
What was that?
Entry, descent, and landing.
Daniel?
And to bring all together human robotic interfaces.
Great. Oh, awesome answers. I really like that. That was a good one. So I'd like to ask you all to thank our panelists for being here. Great. I hope it gave you a good sense of what's going on and where it's going.
Thank you.
Thank you, guys. That was great.
Thank you.
Thank you. Thanks, guys. That was great.
Thanks. My pleasure.
Thanks, Amit. Yeah.